This is an RNZ podcast.
Ngā mihi nui, and welcome to Elemental, a podcast from RNZ, in which we're visiting all the elements on the periodic table alphabetically to mark 150 years since it was first published. I'm Allan Blackman from the Auckland University of Technology.
And I'm Alison Ballance, and this is episode 44 of Elemental, which I think is a good one for buoying your mood and putting some pep in that electric car. Brum, brum, and all of that. But before we go there, give us the lowdown, please, Alan.
Okay, lithium, the name comes from the Greek word lithos, meaning stone. It has an atomic number of 3, its chemical symbol is Li, and it was first discovered in 1817.
So when I do the periodic table, hydrogen, helium, lithium, it's a metal, but it's coming hot on the heels of hydrogen and helium right at the top there, so can I take it from that it's really light?
Yes, indeed it is. And you're right, it comes right at the top left-hand corner of the periodic table in Group 1. It is the lightest metal on the periodic table. It is the least dense solid element at room temperature and pressure on the periodic table. And it's the most reducing of all elements.
What do you mean by that?
Oh, I was hoping you were going to ask that. Okay. If it's very reducing, what it means is that lithium desperately wants to give up its single outer electron. Being in Group 1, it's got a single outer electron. It wants to give that up, and it wants to form lithium ions Li+. And because it's very, very reducing, that makes it really, really useful in lithium-ion batteries, which I'm sure listeners will have heard of. And lithium-ion batteries are used extensively in electric cars, and so therefore, with the expected explosion in the number of electric cars on the planet, you would imagine that lithium is going to be very much in demand in years to come, which is brilliant for both Chile and Bolivia, because they've got the largest known deposits of lithium.
Now, we don't usually think of metals as being great medicinally, but lithium is widely used, isn't it?
Yes, indeed, and it has found use in the treatment of bipolar disorder, and the story behind this is very interesting in my view anyway. So there was an Australian doctor by the name of John Cade, and he was working in 1949 looking at manic depression. And what he was doing was taking the urine from manic depressive patients and injecting it into guinea pigs. For what reason, I'm not quite sure, but what he did find out was that all the guinea pigs died. And so he thought about this, and he thought that maybe it was due to uric acid in the urine that all the guinea pigs died. So what he did was, instead of uric acid, he made a solution of the lithium salt of uric acid to see whether this would kill the guinea pigs. He gave it to the guinea pigs, and rather than killing them, what he found was that they became very, very lethargic, but they recovered to be their normal selves in a few hours. Instead of the lithium salt of uric acid, he then tried lithium carbonate because he wanted to see whether it was lithium that was doing this. And what he found was that guinea pigs, now everyone knows that guinea pigs are not the most docile of animals, fairly nervous. And what he found was that when he took this lithium carbonate and gave it to the nervous guinea pigs, they became very, very docile. To cut a very long story short, he eventually took lithium carbonate and he tried this on his most disturbed manic depressive patient. And this guy had been in the secure unit for 5 years. When he started his lithium carbonate, within 2 months, he was able to go home and return to his old job. Quite remarkable, absolutely unheard of in those days. And so that's how lithium, specifically lithium carbonate, became a treatment for manic depression. Now, I can tell you all about how lithium works in a battery, but even today, nobody is really sure how something as simple, and it is simple, you can't get much simpler than a lithium ion, how this simple drug works in the human brain. It's quite remarkable.
Batteries, brains, how else do we use it?
Being in Group 1, it's very, very reactive, so I'm sure many of you perhaps at school would have thrown lithium into a beaker full of water and watched it fizz around on the surface and form lithium hydroxide and hydrogen gas. And if you're lucky, the hydrogen gas would burn. But lithium, being very, very reactive, actually reacts directly with nitrogen gas in the atmosphere. That's very, very unusual. And it forms a thing called lithium nitride, which has the chemical formula Li3N, if anybody's interested. And lithium Now, as I said, it's the lightest metal, so it's going to be good for alloying with because it's got very, very low density. So what we find is that if we make aluminium lithium alloys, we get strength with lightness. And so those are important alloys in planes and bicycles and high-speed trains. Also important in fireworks. The beautiful, beautiful red colour that you see in fireworks very probably is due to lithium salts. And lithium chloride is used as a drying agent in air conditioning systems, so that takes the water out of the air due to the fact that it is, and this is a really good word, hygroscopic.
It likes water?
Yeah, pretty much. Yeah. So it absorbs water from the atmosphere, essentially. We'll say that, yeah.
Now, we've covered off planes, trains and automobiles, and I think you can add space rockets to that list?
Oh, yes, indeed you can, because when people go up into space, they're busy respiring, and when they respire, they are forming carbon dioxide. And you've got to get rid of the carbon dioxide, because if that builds up in your capsule, then it's going to kill you eventually. One way of getting rid of that is reacting the CO2 with hydroxide ion. And the lightest source of hydroxide ion that you can possibly come up with is lithium hydroxide. And so that is used in basically all space flights to get carbon dioxide out of the craft. The product of that is lithium carbonate. Now, the crew of Apollo 13 had very, very good cause to thank or be thankful for lithium hydroxide, because if you know the story of Apollo 13, they had an explosion on board and they never did make it to the moon. So they had to sit in the lunar module for a few days very uncomfortably, and it was not at all sure that they'd get back to Earth. And sitting in the lunar module, they were busy exhaling lots of CO2 because they were probably understandably pretty nervous. And their lithium hydroxide capsules were in the command module, most of them, and they were the wrong shape. So they had to do a Heath Robinson kind of manipulation on these lithium hydroxide capsules, which were the wrong shape, get them into the right shape, and luckily they got back to Earth in one piece. Pretty amazing story.
It is an amazing story. So they didn't get to land on the moon, but they did get home safely. But funny enough, when I mentioned space rockets, I don't think that's what I was thinking of. It's very cool. And it's come to me what I was thinking of in the Star Trek universe. Dilithium crystals are a key part of the faster-than-light warp drive. And
Yes.
they were always looking for more. It was an ongoing gag in the series. I take it they actually made dilithium up?
No, they didn't. In the real world, you do get a molecule that contains 2 lithium atoms, which has got the formula Li2. We would just call it a lithium molecule. So it does exist, but no, not yet. We haven't found a way of making a warp drive using dilithium crystals, so sorry to burst the bubble on that one.
No worries. That's what you're here for, Mr. Chemistry Professor, to enlighten us about the truth and open our eyes to the real wonders of chemistry, not the made-up Star Trek stuff. You've been listening to episode 44 of Elemental from RNZ. You can subscribe to us for free on your favourite podcast app.
Or you can find us online at rnz.co.nz/chemistry. And we're back next time with lutetium. But for now, I'm Allan Blackman.
And I'm Alison Balance. Mate wa.